All right, so in our last lesson, we were learning how to simplify exponential expressions. And so far, we've learned two different methods. We learned about what happens when you multiply with the same base, you add the exponents, and we learned about the zero rule, which means if you ever have a power to a zero, that means the answer is actually just equal to 1. So I believe here we're on like the first page, the back of the first page, where we have the exponent rule. So open up your packet to the first page. We have rule 1. We already have that complete, but now we're learning rule 2 today. Rule 2 is dividing powers with the same base. All right, so when dividing powers with the same base, you do the opposite of when you're multiplying them. So when you're multiplying, you add the exponents. When you're dividing, you subtract the exponents. Okay, so in that blank there, you should put subtract. So when you have the same base, like in this example A, 12 to the 6th over 12 to the 2nd power. The bases are both the same. Because these bases are the same, that means what I can do to simplify this is use this second rule, which requires you to subtract the exponent. So here's how it works. You would just take 12 to the 6th power, 12 to the 2nd power, and that's going to be equal to 12 to the power of 6 minus 2. Well, 6 minus 2 is 4, so this answer is going to end up being 12 to the 4th power. The reason why this works is because 12 to the 6th power is 12 times 12 times 12. I guess I have to use times 12. I need 6 of them. So there's 4, 5, 6. And 12 to the 2nd power is just 12 times 12. So when you are simplifying stuff like this, what ends up happening with this division rule is that each 12 on the top will cancel out with one of the 12s on the bottom. So 2 of the ones on the top will cancel with 2 on the bottom, and you're going to be left with just these 4. 12 times 12 times 12 times 12 is equal to 12 to the 4th power. That's where this comes from. So the rule only works if you have the same bases. The bases are both 12. They were the same, so it works for this. The next example, we have variables, but still, even though we have the variables, the variables are the same. So b to the 9th power over b to the 3rd power. To simplify this, this will be equal to the b to the power of 9 minus 3. Now, you don't have to show me this work. You could just do b to the 6th power as your final answer. That's what the final answer will be because 9 minus 3 is 6. The reason why this works is because there's 9 b's being multiplied on the top, 3 on the bottom. So when you use cancellation, 3 on the top will cancel with 3 on the bottom. You'll be left with b to the 6th power there at the top. All right, so what we're going to do now is practice this rule. If we flip this over to the next page, actually, I guess not the next page, but it looks like this. It says exponents and division, so maybe 2 pages after. Just like we did last week, we're going to do a couple practice problems together, and then I'm going to give you the rest of the period to work, and then we'll go over the answers before the end. So, simplifying exponential expressions. Number 1, if I wanted to simplify 5 to the 4th power over 5, first thing you have to realize is that 5 at the bottom has an invisible exponent. What invisible exponent do we have here? A 1. So if this is helpful for you, you can write the little exponent of 1 there so you can see that it's 5 to the 4th over 5 to the 1st. Not necessary though, but it might be helpful for you to do that. When you're simplifying these expressions, the bases for both of these are the same. The base is both 5, so I can use the division property, which means I take the exponents, which is 4 and 1, and I subtract them. 4 minus 1 is 3. So this ends up being 5 to the third power. You can leave your answer just like that. 5 to the third power can be put into a regular number because we could do 5 times 5 times 5 and get 125 as our answer. But you can leave all of your answers in exponential form, meaning you still have a number with exponents, and that's fine. Now, number 2, so we're going to move over to the right. Number 2 is going to be the first time we see a weird situation like this. So number 2 is going to be 3 to the first power. That's going to have an invisible 1 over 3 to the third power. So when we use this rule, because we can use the rule since the bases are the same, when I go to show my work here, because I'm going to show you the work for this one, I'm going to get 3 to the, I always take the numerator exponent and subtract the denominator exponent. So this is the first situation that this interesting thing's going to happen. When I take 1 and I subtract 3 from it, what type of number am I going to get? A negative. So when I take the 1, I subtract the 3, I'm going to get negative 2. So this is going to be 3 to the negative 2 power. With exponents, you can never have negative exponents. So we never want negative exponents as our final answer. So in this case, what that means, since this is a negative exponent, it means that this exponent actually is going to have to be in the denominator. So that's because I took 1 of them in the numerator and subtracted 3 in the denominator, which means there's actually 3 to the second power in the denominator. There's 2 left in the bottom, and there's nothing in the top. So that would just simplify to be 1. So this ends up being 1 over 3 squared, or 1 over 3 to the second power. Now let me show you why. So if I use the expansion rule and I take like 3 to the first power, which is just here, and 3 to the third power is down here, so 3 times 3 times 3. When you're using these rules work because in fractions, when you have the same thing on the top as you do on the bottom, they'll cancel out. So one of those 3s to the top will cancel with one of the 3s at the bottom. And see how I'm left with the 2 3s at the bottom? That is where I'm going to be getting the 3 squared from at the bottom. And because the 3 at the top canceled out, I'm left with just nothing there with, in this case, in fraction form, it would be a 1. So that's where it comes from. And it is a little confusing when you use this rule and you get a negative, but that's how it works. Same type of thing is going to happen with number 3. Number 3 is 2 squared, which is 2 times 2 at the top, and 2 to the third power, which is 2 times 2 times 2 at the bottom. So if I was using like this cancellation rule, one pair of 2s will cancel here, one pair will cancel here, and I'll be left with 1 2, but it will be at the bottom. So because I'm left with it at the bottom, I would have to keep it in the denominator. And when everything cancels out in fraction form, you're left with just 1 at the top. So this answer is 1/2, and that's using the, not the rule actually. The rule says if you have the same base, so these 2 bases are the same, I can take the exponents and subtract the numerator minus the denominator 1. Well, 2 minus 3 is equal to negative 1. So I get here 2 to the negative first power. And this is a little strange because when you have a negative exponent, what that means is you have to take the 2 to the first power and put it in the denominator. 2 to the negative first power is really 1 over 2 to the first power in the denominator. This is something we have to memorize, and it is very strange. Whenever you have a negative exponent, you have to put it into the denominator if it was in the numerator. Whenever you have a negative exponent in the denominator, vice versa, you have to put it in the numerator. So basically, negative exponents are going to change the location of where the exponent needs to go. So sometimes it's a little confusing when you get the negatives. You can always do it this way if you are stuck. But this answer would end up being 1 over 2, or you can say 1 over 2 to the first power. So I'm going to skip 4 because it's kind of similar, and I'm going to, let me see. I want to do one that has a little bit more stuff going on here. So I'm going to do number 7. So number 7 says 10p to the 4th power over 6p. So in order to simplify this, first things first is I have 2 separate things going on. This is 10 times p to the 4th power over 6 times p. These 6 and the 10 are not attached to the variables. So they're like separate numbers being multiplied. So when I go to simplify this, the 10 and the 6 can be simplified like a normal fraction would be. So if I gave you just a regular fraction and I said simplify 10, if I said simplify 10 over 6, what would you do to simplify that? Molly? Yes. So you would divide both numbers by 2, and you're going to get 10 divided by 2 is 5, 6 divided by 2 is 3. So this fraction can simplify into 5 on the top and 3 on the bottom instead of leaving it as 10 over 6, because I can divide both of those by 2. And then if I'm looking at the exponent rules, I have p to the 4th power over p to the 1st power. I can now use the exponent rules, which says if you have the same base, which in this case we do, p to the 4th over p to the 1st. What you can do to simplify that is take the variable and subtract the exponents from the top to the bottom. So p to the 4th over p to the 1st can be simplified into p to the power of what? Yes, 3. So this is going to be p to the 3rd power. So here's what happens. When you get a positive answer for your exponent, that means that it's going to go in the numerator. So it's going to be the 5 in the numerator already. And then this simplifies, this whole thing here simplifies to be p to the 3rd power. And then the denominator is just going to be the 3 because the p on the bottom ends up canceling out. This answer would be 5p to the 3rd power over 3. So what I want you guys to do, I know this stuff is really hard and it's weird. I want you to try your best to complete this page and only this page. If you finish a little early, just give yourself a little mental brain break. And then we're going to go over the answers in like 10 or so minutes. You can work together. You can ask me questions. I really want you guys to focus hard on this because this is like one of the most difficult lessons in this section. So work together, ask me questions, and in 10 minutes we'll come back together.